If A and G be the arithmetic mean and geometric mean respectively between two positive numbers, prove the following. So we are looking at two numbers, say A and B, be the two numbers, or let me use M and N, with the two numbers whose arithmetic mean is A and geometric mean is G. So we have been given that arithmetic mean is equal to A, which is equal to A plus B by 2, while geometric mean, which is equal to G, is equal to square root of AB. So this is all that the information, set of information that is given. We have to prove that M and N, right? Oh, sorry, I changed the variables, is it not? This is M and N and this is Mn. So we have to prove that M and N both are equal to that particular expression. A plus or minus square root of A plus G into A minus G. Okay, so how will we solve this? So basically we have to solve. So we have two equations. To find one of both the variables, we have to use both the equation, right? So what will I call this as is 2 and this as 1. So we will start off with from 1 and 2. So from 1 I get an expression and substitute in 2. Basically that's what we can do, right? So let me substitute that now. So we have A plus M plus N is equal to 2A. So I'm going to substitute M as 2A minus N, right? So let's do that. Substitute M in 2. So what will happen? G square is equal to 2A minus N into N, right? So the next set of steps are something that you can skip. So basically this is G square is equal to 2an minus n square. So finally you will be able to write this as n square minus 2an plus G square is equal to 0. Agree? So remember, you need not write all the steps. Whatever is required, you should be able to write that. Okay, so we have this. Now what is the next thing? See, I just want to make a small note here. When I tell here in this equation, n is a variable, while A and G are constants. Remember, we started with M and N as the variable, is it not? And A and G are a number, just that it's represented with a capital letter A and G. It can be 10 and 14, whatever. So we don't know that. But what we are looking at is what? A quadratic equation, A square minus 2AB plus B square. Not exactly of that form, but yeah. A square minus 2AC plus D square, something like that. So we need to solve quadratic equation using quadratic formula. So as per the formula, we have n is equal to minus b plus or minus square root of b square minus 4 ac, this entire expression divided by 2 into a. Further solving it a bit, so this is 2a plus or minus square root of, so this is 4a square, so I'll take 4 common, so a square minus d square, this entire thing divided by 2. And I can rewrite this as 2a plus or minus square root of 2, right? Actually, I need a line. Plus or minus square root of 4. My bad, not 2. 4 into square root of a square minus g square. This entire thing divided by 2. Okay. So how is that I got this out? This is because of ab whole to the power of n, which is a to the power of n into b to the power of n. So basically, I'll be able to cancel this and this and this. So we need to understand how is that possible. See, we have this to be common. And using distributive property, which I have not shown, which you need not show. Distributive property. What do we have? We have this 2, and this 2 getting cancelled. And finally, we have n to be equal to a plus or minus square root of a plus g into a minus g. How is that possible? Well, we are making use of a square minus b square formula, which is a plus b into a minus b. Closing the brackets. And we have n also, right? Should we do the same thing again? No. We can just write similarly. We can prove m is equal to the same set of expressions, right? I'm not going to write that. Hence proved. Right. Yeah, we can pause and have a look.